Hello everyone, welcome back to BC Calculus. We're currently in lesson number 37 where we're talking about the elimination of perimeter. So in the first video we talked about linear functions pretty easily, and so in this one we're going to talk about more complicated functions and the strategies that we want to do. Notice that 3 of the 4 examples we're going to do in this video are a trig, and you do all 3 of them the exact same way. So let's go ahead and start with example number 3, where I want to say that x is equal to cosine of t and y is equal to sine of t. I'm restricting it on the interval from negative pi over 2 to pi over 2. And so t is going to be the perimeter of our functions. And so one of the things that we need to do is we need to eliminate our perimeter, and we do not want to use arc, cosine, and arc sine here. That would be a very crazy, that'd be a really crazy mess. So let's square both sides. And like I said, this is how you do every single one of our trig function problems that at least we're going to do in this class. So we're going to go ahead and do cosine, or x squared equals cosine t squared, and then y squared equals sine t squared. And what we're going to do is we're going to set the left equal to each other and our right equal to each other. And this should make sense. If x squared and cosine squared are equal to each other, well, there they are on one side. So this could be 5 and 5. Awesome. And if these are equal to each other, this would be 5 and 5 as well. That's back 7 and 7. So there you go. We can do this. Well, you guys know from identities that this guy right here is actually equal to 1. It's actually equal to 1. So we have, again, a circle. Now, one of the things I forgot in the first video is, for example, number 2, which was his exact example, where we end up getting x squared plus y squared equals 1. I didn't talk about the domain and range. Well, I can do it here because it actually is going to be the same thing. So we know the fact that it's going to be a circle, so we got to figure out what part of the circle we want, and the direction of the circle, and all that stuff. So one of the things that I really do like for people to do is put our perimeter here. And so at negative pi over 2, this would be our x, this would be our y, and then kind of get an idea of what's going on with our problem. So when we plug in negative pi over 2 to cosine, or even pi over 2 into cosine, well, pi over 2 and negative pi over 2 is going to be 0 and 0. So we know these are going to be 0 and 0. If I plug in negative pi over 2 to sine, well, that puts me in the 3 pi over 2 family, right? It's over here in the bottom of the quadrant. So I know that y is going to be negative 1. And then if I plug in pi over 2, I'm going to get that this is going to give me 1. And we can go one step further and say, okay, what's going on at 0? And this is what I tried to do in the last example. So if I plug in 0, because it's in between the two, so what's going on with this? Well, cosine would be 1, and then sine would be 0. So this gives me an idea of what's going on in this picture. And so again, we know we're going to have a circle. We know we're going to have a circle of radius 1. That's what the graph looks like. So when t equals negative pi over 2, then you're going to be at the point 0, negative 1, which is what we did last example. At 0, we're going to be at 1, 0. And then at pi over 2, we're going to be at 0, positive 1. So we know that our function is going in this direction. And again, that's just simply plugging stuff in. So we know it's a circle. It's actually a half a circle. We know the direction's going here because this is our starting value. This is our final value. And our domain in this problem is just simply going to be the x value that we have. And we clearly can see that domain is going to be 0 to 1. And then our range is going to be from negative 1 to 1. Because again, you can visually see that graph with this right here. So that's the first strategy, first example that we want to do. So you want to square cosine, square sine, and then start figuring out how to interact these things together. And so, oh yeah, x squared plus y squared equals 1. That's awesome. So let's look at something like number 4. So for example, number 4 gets a little bit more complicated. The goal is always to get your trig function by itself. That's always the best thing to do. So for this example, we've already had that. Here, let's get the secant and the tangent by itself. So I'm going to move negative 2 over, or I'm going to subtract 2 from both sides. I'm going to divide by 6. So I'm going to go ahead and divide by 6. So I get x minus 2 over 6. And I'm going to leave it there for right now because that's fine. I don't need to simplify that anymore. And then over here, I'm going to subtract 3. Well, this is actually pretty awesome. We just have this. So one of the identities that you guys learned from Pythagorean, you learned that cosine squared plus sine squared is equal to 1. That's awesome. Well, another one that you should know is that tangent squared x plus 1 is equal to secant squared x. So this is one of the other identities that you guys learned back in pre-calculus, pre-calc honors. So what we're going to do is we're going to square both sides like we did over here, and let's do that. So tangent squared is going to be y, right here, y minus 1 quantity squared plus 1. And then secant squared is going to be x minus 2 quantity squared over 36. So I just squared the top and the bottom. You guys will see why I'm doing that here in a minute. So what's going to end up happening is I want to move the y minus 3 squared over to the right-hand side. And so I'm going to get x minus 2 quantity squared over 36 minus y minus 3 squared is equal to 1. All right, so I just flip-flopped it. So I just moved this over here to get this. So you should know what this is. You should know what this is. This is hyperbola. So we at least now know what our actual function is going to be. So we know that that's going to be a hyperbola. There's many ways to talk about the graphing of the hyperbola. I'm not here to really do that. We do know that the center of this hyperbola, well, the quote-unquote center, because it really isn't one, but it's going to be at 2, 3. So I know that at 2, 3, 1, 2, 3. So here we have this. And then what you guys just need to remember is that, remember, this is plus or minus 6. So take square root of this. So 6 to the right would be at 8. 6 to the left would be at -4. And then we would go, this is over 1, so this would be plus or minus 1. So we would go up 1 and down 1. So down 1. And then, you know, what most people learn is to draw the little box, like so. And then you draw the arrow, the little lines through. I cannot draw, so something like this, just to get a visual of what the graphs look like. You want your arrows to go through the corners and the middle of the thing, and then you draw yourself this way. And you're drawing it in this direction because x is the positive one. So you're not going up like this, you're going like this. And my enter key online is so much better than this, but that's the idea for this. So this is what the graph looks like. Notice that we're not restricted up here, so we want the whole thing. We want the whole thing. And then if we're looking for domain and range for this problem, well, domain is going to be negative infinity up to -4. And then it's going to go back to 8 to positive infinity. And the range is going to be all real numbers, because y can be anything from here and here. So the point of this problem really isn't to graph this thing. It's really just to make sure that you guys can eliminate the perimeter very easily by, again, isolating your trig functions, squaring both sides, looking at the Pythagorean triple theorem that we have to do here, and plug in, and then say, okay, if I move this over, remember, if this had been plus, which we're going to get to now, we're going to skip into example 6 now. If this is plus, this would be an ellipse. So you guys are going to see all of the different conics that you've done here. All right, so hopefully this is making sense. Let's look at example number 6 and keep on going. So for question number 6, it's saying, okay, let's again eliminate the perimeter. Again, ladies and gentlemen, we want to isolate our trig function. So we want to get the cosine of t is equal to x plus 1 over 2. And then y minus 1 equals 3 sine of t. And then sine of t is going to be equal to y minus 1 over 3. So we're going to square both sides. We're going to get x plus 1 quantity squared over 4. I like to do it like this, guys, because we know that this is going to end up being, a conic. So I like to just, don't actually square the whole top and bottom like that. Just I do them separately like this. And then do y minus 1 squared over 9 equals sine squared x, or t. And just like in example number 3, where we actually said, okay, well, let's take this side plus this side equals this plus this. I'm going to kind of skip around a little bit here. Hopefully you guys are okay with this. If I can say x plus 1 quantity squared over 4 plus y minus 1 quantity squared over 9, that's simply going to be equal to cosine squared plus sine squared. Well, we all know that's going to be 1. We know that's going to be 1. And so because now we have a plus here and positive, we're adding x squared and y squared and positive, then we know that we have an ellipse. We have an ellipse. Again, we're not restricted here. And usually for these conic sections, we're really not. So for an ellipse, we know that we are at the point -1, 1. So at -1, 1, we're at a center. And then the x says that we're going to go to the right 2, left 2, and then this is going to be up 3 and down 3. So our ellipse looks something like this. And if we were to look at the actual values for what we did here, we would count, from this point 2 to the right, 2 to the left for our domain. We would get -3 to 1. So this would be -3. This would be +1. And then for the range, we would go 3 up and 3 down from our center point, which again, our center point is going to be negative 1, 1. So I'm just now going 3 up and down from 1 is what this ends up being. So negative 2, positive 4. So eliminate the parameter, isolate trig functions, use the Pythagorean triple identity thing that you guys have to get a function, and then using your knowledge of conics to figure out, okay, what is it? And then using more knowledge about conics to figure out how to graph the thing and then figure out your domain range. All right, last example is the only other conic that we haven't really talked about yet. And let's look at this one. So I'm going to go ahead and solve, which should be the only way I can solve this is really that I got to solve for this because this is hard to do. You have to isolate a t, you can't do that. So I'm going to get t is equal to y plus 3. And I'm going to go ahead and plug in t everywhere I see a t in this problem right here. So I'm going to get y plus 3 squared plus 2 times y plus 3. And then I'm going to start simplifying this because I want to know what the shape is. I want to know the domain and range. I want to know the behavior of the graph. So I'm going to get x is equal to y squared plus 6y plus 9 plus 2y plus 6. So x is equal to y squared plus 8y plus 15. So you guys automatically know this is going to be a parabola. It's going to be a parabola that's going to be in the direction of this, right? Direction of this, because again, x is equal to, and the y component is positive, so we're just going to look at something to that effect. So we want to do some algebra to figure out kind of the idea of what's going on for this. So if we factor this guy out, we can figure out where our y values are going to be. So we're going to get y plus 5, and we're going to get y plus 3. So we know that y equals negative 5 and y equals negative 3. We're going to look at the graph. So let's go ahead and do this. Let's put it up here. So at negative 3 and negative 5. So we know it's going to cross at negative 3 and at negative 5. We also know that we could do a couple of things here. We know the graph is going to, again, go this way with it. We know the graph is going to look like this. We could use our number line system. We could plug in negative 2 to our values and figure out what happens here. So if we plug in negative 2 here, y, we're going to get negative 5. We plug in, again, I'm just doing the number line that I did, the little table that I did right here in that one. But I'm just not writing it down. So if I plug in negative 2 here, I'm actually going to get 0. So I know that my first coordinate is actually going to be right here. So this is my start. And then if I plug in, let's say 3, well, if I do 3, y is going to be 0. And then x is actually going to be 9 plus 6, which is 15. So all the way over here, this is going to be 15. And I know the behavior of my graph because I know what a parabola looks like. So it's going to look something like this. It doesn't matter what's going on out here. I don't really care. We can easily find what this value is in a minute, but we don't need to find it right this second. But that's the idea of the graph. And again, we know that it's looking like this. And guys, mostly what I'm doing here is I'm just assuming that we know the behavior of our conic sections and stuff like that. But I just plugged in, like I said, negative 2 and 3 to figure out our end behaviors. We know this is a parabola. We know it's opening on the positive x-axis. And we have our zeros here and here. In our problem set right here. But what is our range? Our range is going to be from negative 5 to 0. We know our upper bound for our domain is going to be 15. And so we need to figure out what this guy is right here. And so we actually know that when y equals negative 4, this is going to give us our value. This is going to figure out what our x value is. So if we plug in y equals negative 4, which we're going to use right here, we're going to get t minus 3. So we're going to get t is equal to negative 1. Therefore, we can go into here and we get that x equals negative 1 squared, which is 1 plus 2 times negative 1. We get 1 minus 2. So we get that our correspondent here is going to be negative 1. So our x value will be negative 1. All right, guys, I hope that makes sense, and I will see you in the next video.